was the initial thing they wanted the no-code technology for was so that everybody in the office could go create bots to make them more productive.
Hey GovCon Giants family, your host, Eric Coffie. Today, welcome to another episode of the GovCon Giants podcast. If you are new to tuning into our show, you've never heard of us before, welcome, welcome, welcome. We interview the best and brightest minds in the world of federal procurement. Sometimes we interview contracting agencies and determining how we can become better small businesses, what things should we be looking for, what's coming down the pipeline, opportunities. Sometimes we interview small businesses, private contractors who have successfully won maybe the Inc. 500 awards, or they're growing their small business into a mid-sized or large organization. And today we feature a technology company founded by Jerry and James who decided to come together to create a business focused on AI. And as imagine, a lot of you out there, particularly those in technology, realizes that there's such a huge focus right now on artificial intelligence. And so Jerry and James decided to put their decades of experience together to create a company, CIWRX, who's now actually exploring the wide world of federal procurement. Today, what we're going to discuss in this is all about artificial intelligence and also how the two of them and CIWRX has access to more than 50 patents. And so they are based in Omaha, Nebraska, and they're really taking this AI thing to the next level. At this time of the recording, their technology is being explored by several agencies for practical use. So stay tuned for today's episode where we interview these great next generation superstars in the world of federal procurement, Jerry and James of CIWRX.
Well, I'm Jerry Ladd. I'm the president of CIWRX, and I've been working with Jim here for about 5 years. And Jim is a technology-based guy, and I'm more the business-based. I'm kind of serial entrepreneur, been around for a little while. 12 different companies that I've been involved with. Some are publicly traded, some are privately held. And I guess my expertise would be more along the lines of the mergers and acquisitions. So I did a lot of business-related acquisitions and bought some things out of bankruptcy, sold some things through different brokers, have done the road shows and all that fun stuff on the West Coast, East Coast, and have been funded and have done the PPMs and all the other fun stuff for growth and business and understand business pretty well. And I'm not very technical. On a scale of 1 to 10, I'm probably a 2 technical. And Jim's probably closer to about a 15 on a scale of 1 to 10. So that kind of tells you that. So I'll let Jim talk about him. There you go.
I'm Jim Babcock. I'm the CEO for CIWRX. I've been in technology since I was a kid, a serial entrepreneur as well. Had all kinds of different tech companies, but an interest I've had from, going back to the 1980s has been in artificial intelligence. And so really, whether it's programming, database, practically any, related area related to technology, pretty much, I've got decades of experience doing cybersecurity or whatever.
Okay. Now, how did you two come together?
Let me tell the
Jim,
story.
I'm gonna have you tell that story.
Yeah.
You tell it a little bit better than I do. Go ahead.
So back in the 1980s, Jerry had a company and had some.
1 second, Jim. Before we get into the story, tell us what CIWRX is and what is it that you do?
Okay.
And then we'll jump into the story.
Okay. CIWRX is a company that Jerry and I, and actually there was a third person who was an ex-FBI agent. We started the company about 5 years ago. And what we do is we do data management, cybersecurity, artificial intelligence. We've got a software platform and we have lots of people. And the purpose of it is our focus is we do work for government and for private businesses or public business as far as that goes. And really has to do focused really around data management and artificial intelligence with cybersecurity mixed in.
Okay. Now you can tell us, how did you guys come together?
Well, in order to tell the story that about how we came together to create CIWRX, which happened 5 years ago. I need to tell you a little bit about the 1980s. Back in the 80s,
Okay.
Jerry had a company, and he was providing contract programmers. And I hired a group of his people, including one of them who was from Switzerland, a good friend of ours, Matt. And Matt and the project was in Lincoln, Nebraska, and I was living in Omaha, Nebraska. And so when Matt came over from Switzerland for this project, I said, you should get an apartment in Lincoln. And he says, no, you're living in Omaha. And so I'm going to have an apartment in Omaha, and we can drive back and forth 40 minutes each way every day. And I says, okay, if we're going to do that, your primary language, your English sucks. Okay. and my German sucks, but I know German. But the thing is that what we'll do is we made an agreement that driving each way, we would speak only one language. And we did that for over a year. And we got to be really close as families, his family and mine. Well, then years later, I'm still friends with Matt, and Jerry is as well. And whenever Matt comes to the United States, he always stops by, and we always spend time together, my family and his family. About 5 years ago, he came to the United States, and we were doing things. I said, well, what are you doing tomorrow? Let's talk about what we're going to do tomorrow. We would go to the zoo or go different places and go to bars or whatever. And he said, well, I'm going to go tomorrow. I'm going over to see Jerry Ladd. I said, you're going to go see Jerry Ladd? I haven't seen Jerry for a long time. I says, can I go too? He says, oh, absolutely. So the next day we went to Jerry's office, and I had to walk up. Jerry talks about it because he was up at the top of this hill, and we had no idea where this office was. So we had to walk up this really long hill, and Jerry didn't know that I was coming, and he looks down, the hill, and sees us walking up, and we reintroduced ourselves after decades, went in, we talked for a while, and then, in his office was a cybersecurity expert who is retired from the FBI, was also in there. And one thing led to another. Matt went back home, and Jerry and I and Pete is his name, the three of us decided to start a company really focusing on how we can use my expertise in artificial intelligence, how we can use that to help the government.
Okay.
Jerry is the business guy. Pete was the guy who really is the expert at the government, and I knew the artificial intelligence, and so it seemed like a good mix to bring it all together, and so that's how CIWRX was started.
Nice. No, it's a great story. I'm reading your profile, and it says that going back as far as the 70s, you implemented financial networks, ATMs, POS devices.
Yes. Yeah. Yes. Because back in the 1970s, I've done lots of different things, like I said, but the ATMs and all that kind of stuff. There's a company that I was employee number 26 for a company called Applied Communications. They're the ones who invented the ATMs, or Diebold made them. They were the ones who commercialized them. I'll put it that way.
Okay.
And we built the financial networks for how the financial networks work today. And I was working on that. Kind of funny story about the ATMs. I remember Diebold brought in a whole bunch of prototype ATMs. Everybody knows what an ATM is today.
Right.
But these were brand new things, and they had a whole bunch of custom designed ones that they had nobody knew how they were going to work. The coolest thing was that there was one of the prototypes where you put your credit card in, you had to put your hand into this dark black hole.
Okay.
And it reads the credit card number off there, and it would check a list of stolen cards. And if it was stolen, it put a handcuff on you right there.
No. Oh, that's amazing. I like that. Why do we never release that one?
Yeah.
I think they should go back in time, right, and release that thing.
Yeah, there were all kinds of crazy devices, out there that were
Wow.
built, but that was that, for ATMs and such. That was one of them. And so that was a fun story.
Now, it says here also that you started doing AI in the 80s.
Yes,
AI has been around that long?
yes. It's not the same as AI today.
Okay.
Artificial intelligence, really back then, there were lots of different technologies. One of them was called genetic algorithms. There was just knowledge bases. There was all kinds of heuristics and all kinds of different ways to use computers to be able to act like and think that it's going to be more intelligent. And so, as an example, there was a program called Lisa, and Lisa was a AI program, one of the first ones, and it was a psychiatrist in a box. And it's a little program that, imagine, okay, you translating it into current technology. If you think about Alexa, okay, and Alexa, well, this is where you typed on a teletype back then.
Okay, sure.
And it would say, "How are you doing today?" And then
Right.
you would say, "Oh, my day sucks." It says,
Okay.
"Oh, that's too bad." And then it would go on and on and on. But that was considered, artificial intelligence. How do you make it so the computer seems to be more human? Obviously, chess programs are a good example. That's called game theory
Right.
for it. But that's all artificial intelligence. And so I've had an interest in it going back, to those times, and have done, hundreds of projects over the decades.
Can we explain artificial intelligence for like dummies?
Yes. Artificial intelligence is just like the name sounds. It's trying to be able to use a computer, have a computer to seem more human. If we go back to the 1960s, actually, the whole idea was that if you took and had somebody in one room at a teletype, a computer in another room, and then the operator in the third room who's sitting at the teletype, and if me as the operator can carry on a conversation, if the computer, if I can figure out, if I can't tell which one of those is the human and which one is the computer, that's called intelligent. That's artificial intelligence. Making it so computers seem to be more human is what it was, is kind of where it all started.
Okay.
But really what it's all about is being able to make it so that computers can be able to act more, not just more like humans, but more intelligent than a computer program that just follows a list of instructions. And that's kind of some of the problems. Today, how it's all evolved is that because of the amount of computing power, the amount of memory in your computers and all the rest, it's all moved to one technology, which is, it's called a neural network. A neural network is a simulation of a computer that's a simulation of in a computer of a human brain. Okay. And so instead of having all these different kinds of technologies, computers have become so powerful that you can literally simulate a brain inside of the computer. And that's how it's all evolved. And so your self-driving cars, what they have is they've got a neural network in there that gets trained like no different than a person getting trained on how to do something. You learn it, you remember it, but you don't remember, there's not a set of instructions for how to drive a car.
Right. Right.
That's what artificial intelligence is really all about, simulating how the brain works for learning things and then be able to make decisions. And that's where it's all evolved too.
Now, when you, Jerry, and Peter got together and you said, okay, we want to go after the federal government or government contracting, what was the initial idea?
That was the idea. to be able to put our areas of expertise, primarily using my artificial intelligence and Pete's cybersecurity, for the purpose of us just going and seeing if we can get some business. Right?
Okay. And so makes sense. Now, Jerry, what were you thinking at the time?
Well, my thoughts were, here's Jim that's got this background in government work, and here's Pete that has that same type of government expertise. And I had the business knowledge of, of how a private sector enterprise would work.
Right.
All the hiccups and, all the wonderful things that happen during a business
Right.
life cycle that I call them, we'll call them crap sandwiches that you eat during a business life cycle.
Uh-huh.
I knew what those were like, and I thought I could help with not only the profit and loss statement and all the business cycle stuff. I've been chairman of the board of different companies and different types of things on the organizational structure, and I knew how to do that, and I knew how to fundraise, and I knew how to do certain things. I just had absolutely no knowledge of any kind of government industry. So
Okay.
I started kind of slow. I went the typical route that a guy that doesn't know anything about government contracting would go.
Right.
Looking into the SBIR and do as many BAAs as we can and not having any contacts. And
right.
It was an absolute nightmare of a small business with no contacts at a government level, thinking that they were going to just step in and
open the doors and
and the business would just roll right in.
That's right.
Yeah. Hey, don't you know who I am? This is, this.
Right.
So that worked out not so well, but so we started doing that, and then we had some contacts down at the federal base here in Omaha, and we had some connections with Pete at that base, and because of those connections is one of the reasons why Pete had to leave us, so there wasn't a conflict of interest of him working at the base and working with us as well.
Okay.
So that was kind of the separation there of why Pete got left us. But as far as the business side, I had absolutely no problem running the business and doing the board meetings and doing all the the song and dance stuff.
Right.
I just don't know the song and dance for the government step.
Okay. Okay.
So.
That makes sense. No, that makes sense. That makes sense. Now, there's some interesting stats here on your website. I'm looking at your website, and Jim, I see on here where you talk about 90% of the world's data was created in the last 2 years. 80% of this data is unstructured.
Yes.
How is that possible?
What do you mean?
I mean, that just seems unfathomable to me.
So again, this goes back a little bit to the artificial intelligence and why that's important. If you think about how the vast amount of data out there on the internet, that data, anything that's on the internet is data that is out there generally unstructured. Structured means that it's like in a spreadsheet.
Right. Okay.
Unstructured is this podcast.
Right.
Okay.
Right.
And so because of the internet and how much is being stored on the internet compared to all of the rest of human history, how little was ever stored.
Okay.
Right. And what happens now is we are overpowered by the amount of it's a wave, a huge wave of data that's been collecting since the beginning of the internet. Before the internet was ARPANET, but internet really started in the 1990s. And since the beginning of the internet, it's just been a growing collection of stuff. And most of that data is not structured like in databases or in spreadsheets or along those lines. It's all of the documents and web pages themselves and all the audio and everything else that's being collected. And that's the data that I'm talking about. And what artificial intelligence allows you to do is to be able to have the computer, you have to figure out what questions you want it to answer. I mean, that's always the thing. Jerry says, can you just have the AI go do this? I says, okay, what's the question you want answered? Okay, once you've defined the problem, then you can create an artificial intelligence that can go and it can figure out, digging through that vast amount of data that's out there, figure out how to get an answer to that. So that's all about.
Now, that makes sense. What is the the difference between artificial intelligence companies?
Well, there's companies that.
So, and I'll ask it this way. For example, I know when we did programming, you have all these different programming languages, right? So
Right.
I understand that. Is there a different artificial intelligence languages?
No, it's not. Okay, let me explain it this way. Today, modern, in 2021, when it comes to artificial intelligence, it goes back to the neural network. Okay. And there are a few different, there are three most popular, instead of programming languages, it's which neural network are you going to use?
Okay.
And the three most powerful ones, most popular ones are Google's TensorFlow, and they use TensorFlow in their cars. They use it in all of their technology. Second most popular one is Microsoft's. It's called the Cognitive Toolkit, CNTK. And then the third one is IBM's Watson, which loves to play chess. That's what everybody thinks it Watson about.
Right.
But it's a lot more than that. It's just that neural network has been trained. One of the things it's been trained in is how to play chess, but it's the same neural network. The way when you learn to program, like you talked about with the different programming languages, the most popular programming language really is Python for doing artificial intelligence. But what you're doing is you get a library for the specific neural network that you're doing. I mean, there are several dozen different libraries for neural networks out there, but those three have the vast majority of the marketplace. And our technology, what we do is knowing that those are the most popular, the way that I've architected ours so that it can work with any of those. The customer decides which one they want to use, and it becomes invisible to them, to the user, which one it is.
Right.
One of the big differences is that Google, if you're doing a government contract and if it has anything to do with the any kind of system that can be used for offensive purposes, then Google does not allow you to use that with their licenses. So if you're going to do something like that, you switch over to Microsoft's. Or
what's the name of Microsoft's?
Cognitive Toolkit, CNTK.
Okay. No, nice, interesting. Okay, no, I'm learning. Thank you for. I'm learning all this stuff. And if you said no, I'm taking notes over here as well. So, I'm a little bit of a nerd.
Good.
Oh, well, good. Well, here's a nice thing, Eric. When we first started, you asked me, well, how did you want to go about this business? Well, what was happening at the time, I was going after different types of businesses. I hadn't worked with government at all. So as was going through these SBIRs and the BAAs, I was looking at those. I'd come back to Jim and, hey, can you do this? Can you do this? Can you do this? Can you do this? And it was problem after problem after project after project. And he kind of got tired of me coming back to him and saying, hey, can you do this? Can you do this? Can you do this?
Right.
Well, what he did is he built, he architected a software as a service. He developed this product, XLab 5000, as a product that could kind of morph into any kind of project that we needed to do. So he could stop listening to me chatter and have a solution for every problem that I brought up. So that's kind of why the product was developed the way it was developed and architected, so we could bring on other projects. So Jim, you want to talk about that a little bit?
Yeah, it's really a platform that we built, and again, it comes back to the whole idea of quit reinventing the wheel. Instead of when you were in college, you were talking about learning how to program. Right. And every time the professor gives you a new problem to do, you just start with a blank piece of paper, so to speak. Well, this way we did it to make it so that it can have lots of plugins. You could put, it was designed to be highly secure. For the federal government, there's something called FedRAMP. FedRAMP is a certification for security in data centers, for putting it in the cloud. And what it does is make sure that it's super secure. Well, I've built systems that are FedRAMP certified in the past. And so instead of having to go and have certified or built every one of Jerry's little projects, a whole new thing, and you have to go through that process, how about we go and we architect something that's a base that is certified that I can take whatever we want and put it inside of that and make it so that it will anything we put in it will be secure, including artificial intelligence. But then as we were going out there talking to, so one of the issues, in talking with some of the government agencies, we went out and talked to DARPA and to the Air Force and to a bunch of other agencies. And, they kept talking about, one of the problems with artificial intelligence is that, there aren't a lot of people who know how to design brains. Okay, and that's what a neural network is you have to have somebody who knows how to architect and build a brain. And I do. And so what I did was I said, okay, if that's the problem, like one of Jerry's typical problems, the thing is, okay, take a problem, what is it I'm trying to do? Okay, so I'm going to build a neural network that can build other neural networks. Okay. And so I did. Okay. And then we presented that to the government. And they says, okay, that's a little bit too advanced for us right now. And so, okay, you said that was your problem. Cool, that's how business works. Okay, I need to know what your real problem is so I can go build something, right? And we heard a couple different things. One of them was that, well, neural networks, it's kind of like what I was talking about earlier in the AI neural networks, how you train it. Okay, a question for you would be, do you remember how and the steps specifically you learned that 2 + 2 = 4? You know how to calculate that, but you don't remember how you learned that, right?
No.
And so that's the same problem with neural networks in a computer with artificial intelligence, is that once you teach it something, it can't answer the question, how do you know that?
Right.
How did you learn that?
Right.
So we heard from different agencies, different stories along this line. But they were all the same problem, but different, examples. And here's my favorite one. They says, imagine that you have a car that is intelligent. Think of it as a Tesla. Okay.
Right. Sure.
And which has a neural network in it. Okay. And it's trained so that whenever it sees a stop sign, it pushes the brake pedal, right? Now imagine that a bad actor, okay, had access to your neural network and trained it so that whenever it sees a stop sign and it has a sticky note on it, it hits gas pedal instead. Okay. And they said, we don't trust, the FAA says, we don't trust, that some bad actor isn't going to get into and fly a plane into the ground. And we heard from all the agencies. So they says, can you solve that for us? Okay. And so I came, so I went back and thought about it a little bit. And says, yeah, I got a solution. So I came up with a solution so that you can be able to make sure that you know how every neural network was trained. And so that was one of the projects that we did out of that. The other one was that we heard something that sounds kind of twisted and backwards a little bit, maybe, or something. Is that from the military, they said, there's this problem that we have that we would like to have it so everybody can be able to go into the computer and program it without having to be programmers.
Right.
Okay.
It makes sense.
And so can you solve that? And I said, well, there's a technology called no code. Okay. It's a way of graphically drawing like flowcharts and pictures and to teach the computer how to do things. And so XI 5000, I can plug almost anything into it. So I've got neural networks in there. We've got different projects we've built. We've got data management tools. We've got cybersecurity tools. And then, we end up putting in some different no-code types of systems. So you can completely build database management tools without having to know anything about programming, without having to hire DBAs or any of those kinds of things. And Jerry, why don't you talk a little bit about that?
Okay, there you go. Well,
this is getting exciting.
Yeah, here we go. As Jim was getting more and more tired with me asking him how to do things and can you do this, that, and this for me so we could make some business, all of a sudden he puts the no code situation in there and and says, Jerry, we're going to train you to become the expert in the no-code side of the business. So all of a sudden, the guy that's at a 2 technological base, knowledge base, becomes the subject matter expert in the no-code side of the software as a service. So now when there's any type of project that comes up that requires the no-code development effort, guess which one of us does that business? That would be me. So what we took was the government by their word that the human assets necessary to do artificial intelligence were few and far between, and they needed to have people trained that were not really technical people. I mean, people that are in business and office administrators and engineers and different types of people. They needed to know how to do artificial intelligence and different types of no-code development efforts. So now I can, without any programming knowledge at all, I'm building databases, and I'm actually developing Internet of Things development efforts, and I'm developing programs that do space satellite-based business. So I've actually built all the flows in the no-code that actually can determine what satellites are where and what longitude and latitude, and with the drag and a drop of a flow on the no-code of XLab 5000. So what's really nice about it, Eric, is that it's a secure environment. The XLab 5000 is a secure environment that any application can be put in that it will. Jim didn't mention it, but he's an ethical hacker. So he knew how to hack into different types of things. He's a white hacker or white hat hacker, and he knows how the bad actors think. So he put all of those remedies in XLab 5000 so people couldn't hack into our system. So it's a real secure environment that people can put their own applications in. Say it's a financial system or whatever kind of system it is, they can put it inside XLab 5000, and XLab 5000 will make it secure like a bubble. It's in this security bubble. So I was the no-code developer that actually is throwing applications and developing applications and then putting them inside XLab 5000. So I'm the guy that actually does that. So he proved that even boneheads like me can program. So there you go.
So one of the things on that though that I didn't finish off with is that the number one thing that the government wanted, the military wanted, everybody knows what a bot is, and normally bots are thought of as bad things, right? What it is a computerized robot to go out and do things, right?
Right.
What they wanted was the initial thing they wanted the no-code technology for was so that everybody in the office could go create bots to make them more productive. So they weren't going to be the bad actor type of bots, but the government, when they says, I want to make it so that anybody can go create bots, I'm thinking, and you're the military, and we have a secure platform, and you want us to build technology that will be able to go build bots, right? And they says that's kind of like twisted and backwards and bad. Okay. and they says, no. We don't want people to use your technology for building bad bots. We want to make so that everybody can be more productive in their job and without having to write code to be able to go and build, bots that automate, redundant stuff that the people in the office do all the time.
Right.
I said, okay, I'll build that.
Okay.
As long as it's for good.
Okay. Jerry, going back to you're being the no-code specialist. Can you tell us like an example of something that you did so people can get like a practical example and understand?
One of the flows it's kind of a unique way. It's if you may know about how you drag and drop different things on the screen to make something happen. It would be hard to describe it, but it's where you take little bits of information and you drag that on and you connect those pieces of information to other pieces of information that do certain things. One would be like something that would debug the program. You would connect it to the one button that debugs the program. You would have one button that would initiate a program, and you'd have one button that might do a certain function. It might do a math function. It might do a certain type of calculation. It might do a certain type of database connection. It might do certain types of things. So you drag and drop little modules onto a blank sheet of paper, basically on the screen, and you connect those modules together, and they do a flow that creates some type of program that creates some type of result. So that's basically what it is. We have hundreds and hundreds of these flows that were built, kind of canned flows that do certain types of iterations and solutions. We do everything from RESTful web services, APIs. I can create APIs myself. You could create, Eric, in a week, we could show you how to do APIs where you could do your own APIs. My brother was a programmer, and he's been working on a program for about 10 years. I did it in about 2 days. I mean, it takes very complex things and can make it so non-technical people can be extremely productive in a very short period of time.
So Jerry, why don't you tell them the story about earthquake?
Oh, okay. We went down to the base, and we happened to go to a client site, or not a client site, but a group that we were going to do a presentation to, and there happened to be an earthquake on that certain day. I'm not sure where the earthquake was, but they were in the meeting. They were talking about, hey, we heard that there was an earthquake, and I said, well, just a minute. So during the meeting, while we're in the meeting, I connected a few of our modules together and did a RESTful web service and went out to the Geological Society and
Service, USGS.
I'm sorry, and picked the information on exactly where the earthquake was, what level it was. And so there's different APIs that you can create. And it took me maybe 10 seconds to create the program to do that. So while we're in the meeting, I told them exactly where the earthquake was, how large it was, and I think it was a 6 point something on the Richter scale. But that's how fast you can create programs.
So with a good example of how useful that could be for the right situation is that program that he wrote, which took literally seconds, it can be scheduled so that, think about weather warnings, how here in Nebraska we have tornadoes,
right.
and other bad weather events. Well, if the USGS or other government agency, it has detected that there is an earthquake, or that there, which can cause a tsunami, as an example, if it's out in the ocean, or other types of things, it can, without writing any code, it can automatically text people, send them email messages, it can do notifications. And that's a small example, a tiny one of what it is that it can do. Another example of doing some no-code type of work is at the beginning of the pandemic, we did some work for Johns Hopkins University, gave them access to our technology for their researchers. But we also then created one of these COVID-19 where it asks you, do you have these symptoms types of things,
right?
And that people can go in there and find out, from medical, from our application, again, without having to write any programs, to be able to go out there and be able to create these kinds of technologies for researchers, whether it's that or for public purposes. And this is all done, again, in our technology without writing any code. We've got all different kinds of things. That application Jerry was talking about for his brother that he did, that one is a completely, typical business database application, okay, that a non-programmer built the databases and the user interfaces in a couple days, and it's much more sophisticated than you can do like with Microsoft Access or anything like that. It's way more sophisticated in what you can do, especially with all of its analytics and the AI stuff that's tied into it on top of it.
Now, Okay. So now that you've kind of solved that problem, you know, where's your business at now today, and where are you looking to take it?
Jim, why don't you go a little bit into the IMUA University and talk about
Okay.
what Hawaii's done there? That'd be a good.
Okay. So again, during the pandemic, you know, I love to solve problems. Okay. Tell me where the pain is, where the issue is, and then we can put our heads together and we can come up together with some better solutions. Well, we have contacts to the lieutenant governor in Hawaii, and Hawaii, as everybody knows, you know, its economy has always been so based on the travel industry and entertainment. And when the pandemic hit, they were devastated because people weren't traveling anymore.
Right.
You weren't allowed to travel. And so unemployment there was very, 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 very high. And so since we knew the lieutenant governor, we got a hold of him and had some brainstorming meetings together to talk about, you know, okay, you got a problem. Let's figure out how we can help work together to come up with a solution. Well, if you take multiple problems together, you can come up with even better solutions. Okay. We have lots of people here who are unemployed, yes, but we have a lot of people who, even in good times, our industry is so so concentrated,
Right.
that we would love to have it so it's spread out. We would love to have it so that young people, you know, young people on the islands are going through STEM training, you know, science, technology,
Right.
engineering, and math. They're going through the STEM training, but then there's no jobs. Okay, there's
Right.
no work here.
Right.
You know, what does that have to do with the travel industry, right? And
Sure.
and so, you know, these are some of the kinds of problems we were hearing. Well, we came up with the idea of creating what we call a university, where we'll take people who have gone through STEM training, or maybe not even those. We give them an aptitude test to find out where their strengths are. And we teach them everything about computers, from the most basic hardware all the way up to learning how to create applications for businesses using our technology with no code and all the rest, all the way to doing artificial intelligence. And what we did was we heard about another problem that they had, and that is that on some of the islands, they're so isolated that they don't have good internet type of connectivity. And so they said, so, you know, you need to make it so your technology can work on Molokai, as an example, which is a island where it's primarily only natives. And normally they don't like having a lot of people that are from the mainland going there, I'll put it that way. But the thing is they have a saying, you know, there's an old saying that says, if you can make it in New York, you can make it anywhere. In Hawaii, they say, if you can make it on Molokai, you can make it anywhere.
Okay.
And so and there on the island of Molokai, there are only 2 locations with high-speed internet at all. One of them is a government office, and the other one is a hamburger stand. Okay. Those are the only 2 high-speed internet on the island. And so what I did was I took and created a special version of XF5000 that the entire application, because XF5000 is designed to be able to run in any environment. Okay, it can run on laptops, it can run in the cloud, it can run on, you know, transports like airplanes or satellites, or it can run anywhere. And in this case, the thing is, I created a special version that the entire thing is on an external hard drive that you plug into a laptop. And I call it a university in a box. Okay. And so we have training, all the training stuff from training classes, everything you would think about for an online university, except for you don't have to be on the internet. Okay, it's all there on your laptop. And then once every couple of weeks, you need to go to one of the locations where there's high-speed internet, and then sync everything up for the communications with the instructors and all of the rest.
Okay, makes sense.
And so it's
like backing up your computer.
But this is bi-directional communications.
Sure, no, I get it. But I mean, for a regular person example, we have to back up our laptops, we have to back up our PCs.
Right.
So you don't need to do it every day, but periodically it'll ask you for backup.
It's like backups, but it's also like if you on your PC, if you go into the email and you're not connected to the internet, next time you connect to the internet, it communicates.
Fair enough. That's a better metaphor. Okay, gotcha.
Yeah. Okay, so we've also then been contacted by the University of Hawaii, okay, because they've heard about us, and then there are other. They want to. We're working with them to put their culinary school in it with their instructors and with their material. And we started our initial training is in IT because the whole idea is that we are always looking for good technologists.
Right.
And especially ones who know artificial intelligence and know our technology. So the thing is if somebody goes through our university, one of the big differentiators is that if they have an opportunity for us to hire them directly to go and do work, and they can use our technology, which they can use. They could stay at home on the islands to do projects that can be anywhere on the planet. Okay, and so it's kind of that kind of, and so in Nebraska, which is where we're from, there's something that's called Aksarben, which is Nebraska spelled backwards, and Aksarben was created after the Great Depression, and a bunch of business people came together and said, what are we going to do to turn Nebraska around? And they created Aksarben. And so we originally, he says, we need to name our university Aksarben University. And of course, the Hawaiians didn't like that very well. And so what we did is, okay, we talked to them and learned more of the Hawaiian language. And there's a term called that's called IMUA, IMUA. And so we call it IMUA University. IMUA is pretty much about the same kind of thing. It's moving forward. It's turning things around in Hawaiian is what IMUA means in Hawaiian. And so we created IMUA University. It's not an accredited university, but we're working with accredited universities for it. But it was originally created for us to be able to help Hawaii to be able to get their people employed, get them skills, get them, and then we're working with the state government there. Their technology is so antiquated at best.
Right, sure.
And so we're working with them to use their island citizens to be able to go and use our technology to be able to go and improve the technology on the island. I'll give you an example of that. That's kind of an interesting story. In Hawaii, when it comes to unemployment insurance, okay, everybody is used to, whatever state you go online and you fill out some forms and you go through the process. Well, in Hawaii, there were three different ways to be able to get unemployment insurance, to register for it. One is fill out some paperwork. Second is go in to one of their offices, government offices, and somebody will fill out the paperwork for you. The third is to go to this website and fill out the paperwork there. What people don't understand is that the website, all it's doing is it's generating a piece of paper that's the same as the form that somebody filled out by hand. And then what they do is they take those forms and then they give that to another person that works for the government who sits down to a PC that has
types the information back.
Exactly.
But that's how. But the PC that they're putting it in is old DOS with floppy disks.
No,
they're putting it onto floppy disks. Okay, putting the information to floppy disks that then goes to another machine where it gets loaded, and it goes through a series of process of loading and reloading and reloading and reloading. And so our technology makes it so that, that's kind of, Jerry could build this.
Right. Well, the problem with it, Eric, was that there when this surge of unemployment claims came in, so backlogged with things trying to use this antiquated system, and it still hasn't corrected because we haven't implemented our system over there yet. So it's not laughable, but it's almost a very sad state of affairs. And you can kind of see that throughout government in a lot of.
That's what I was going to say. Yep, Jerry.
Yeah.
They're not the only ones. They're not the only ones.
No, it's kind of like that, and I always have a question if it's by design or if they're really.
Right.
flow. So I think they're trying, but I think they're just behind the times. But to bring up a real good point that Jim was talking about. I mean, the contacts over on in Hawaii are really important going forward because each community is very knowledgeable about their community, and every different group has their own subject matter expertise. So every community has a different need, every agency has a different need. And what's really unique about this system, everything can go inside of XLab 5000 and it becomes secure. So it doesn't matter if you have all kinds of bad actors. Imagine if there's no internet connectivity. It's pretty hard to hack into something that doesn't have internet connectivity.
Right, sure.
So think about that university in a box in a secure government agency environment.
You know,
yeah, so here's another part about it is that the students are the ones who are going to create that application. Okay.
Right.
But not just that, but when you go to not just Hawaii, and I'm not picking on Hawaii, it's just where we started.
No, of course not.
But when you go to other isolated islands or other countries or whatever, other parts of the United States that have limited access to high-speed internet, or who have bad weather. You know, if you're on an island, you know, we did a little bit of work down
U.S. Virgin Islands.
With the U.S. Virgin Islands when the hurricanes hit. And when you go into those environments and they get hit over and over and over with natural disasters, well, guess what? The local businesses, what do they do for how they manage their books and do everything else? What they do is they do it with paper and pencil, which gets wet and gets thrown away because they're not going to invest in technology that's just going to be destroyed.
Right.
Well, with our technology, we've got solutions for those kinds of situations as well. And so again, the idea is that for our students, for IMUA University, is to have it so that they're not just solving government problems, they're providing help to all their businesses and everything else with solutions that work in these, more challenging environments.
I like that. And actually, when you brought up the no code and you gave the example that the government was saying they have a problem, it reminds me of risk management framework, RMF. Mm-hmm. And talking with people that I know that work for the government, all of these devices have to go through RMF before they connect to the DODIN. And the government was using regular people to do it because they don't have the companies, they don't have infrastructure, they have no one. So they were using regular like Navy staff and regular people to do this risk management framework. So that's the first thing that came to my mind when you start talking about that. Yep. I could definitely see a lot of uses for your platform, the XLab 5000, and what you guys are doing. So, I mean, I can see it. It's pretty clear to me. Now, okay, so you have XLab 5000. Where do you want to go with it?
Well, I would think that initially, we had when we first started the company, Eric, we had a kind of a mission statement. And the mission statement was basically, we wanted to do things for our country for the good.
Okay.
We're both real patriotic guys, and we were trying to do things. I'm probably a little bit more naive than Jim is because he's dealt a little bit more with the government, and you probably are a little bit more at a senior level than I am with the government. I'm a little wet behind the ears, like I said, but as far as our mission statement, we wanted to do good for the government, and we wanted to stop as many adversaries as we possibly could and build a secure environment that any government agency or department or business that was getting hacked would, so we could stop that from happening. And Jim has poured his life of artificial intelligence and cybersecurity. I mean, he's forgotten more about artificial intelligence and cybersecurity than I'll ever know. And so he has built this platform, the software as a service, from the ground up with architecture that's secure and that can let anyone from, it depends on intelligence. There's different levels of intelligence, but if you think of some poor communities and people that are looking for opportunities to advance, it doesn't have to be in the United States. It can be anywhere in the world. We can take this technology and make a technological hub at that location and bring people that are desperate for opportunities to get them jobs anywhere in the world. And that's kind of, I took my background of consulting, rolled that up with the technology and an architecture that Jim had created. And we think we can create a very diverse world of people that are technologically advanced. And that's kind of where we thought the future was going. The government said that they had great needs for human assets, and we thought we could create a system that could actually build those human assets for the government. So.
And looking up the Department of Defense Artificial Intelligence Strategy 2018, you're hitting on a lot of the hot button points that they mentioned. So delivering AI-enabled capabilities that address key missions, cultivating a leading AI workforce, engagement with commercial, academic, and international allies and partners. So, I mean, Jerry, you're touching on a lot of the hot button issues that they mentioned as part of their strategy. So
what is it? Got it from us, Eric.
They went back and said, Jerry's got this thing. I'm gonna write this. Jerry's got this. I'm going to write that. That sounds good. That's what it was. Hey, listen, again, you're saying the same things, right? Whether it came from your, whether you get the credit or not, you guys are saying the same things. That's printed on paper.
There you go.
How can we help? What kind of things? You're here today, you're on our show. If you could speak to someone, what would be your request that you're asking for?
Okay. I'll make this as clever as I can. Eric, we will take help from anybody that is government, business. We don't care. As long as they're a friendly nation, we will do what we can. I think with your show, you can give us exposure to maybe some of the government entities that we are unfamiliar with. Government agencies Jim did work for, but neither one of us are marketing guys. I mean, we're not the song and dance guys out there singing and dancing and all that stuff. But what you could do is any kind of contact level that you would have in the industry, or anyone listening to your podcast would have with industries that are looking for secure environments so they can't be hacked as easily. I'm not saying we're 100% bulletproof, but Jim seems to think we're pretty close. Oh. But places that are looking for secure environments to put their applications, we have a software, a service that they can use.
Okay.
That they need cleaned, and knowing that there's massive amounts of unstructured and structured data out there, but that data is sometimes peppered with bad actor information. We have a full audit trail that can determine what types of things, and it's really simple. I'm not going to say it's simple, but it's pretty easy to build applications with the no code to secure that data and build databases with clean data. So we can help clean up the data, we can put it in a secure environment, and we can make sure that adversaries aren't attacking. So anything that you could get us out to the industry, that people that are tired of being hacked would be more than happy to work with them.
Well, yeah, I mean, really, we do data management, artificial intelligence, and cybersecurity.
Okay.
And we're always looking for projects that relate to those things. Since the world is so full of more data being collected at all times, whether it's structured or not, the thing is we can help clean that. When it comes to cybersecurity, we have a practice where we can come and help, solve a lot of issues there. And the third is that artificial intelligence, once you've done the data management and get your data all controlled, then the question becomes, how can you get some actual information out of that? How do you make it so that, the AI can glean things that normally you can't use just plain analytics to do? And so, that's kind of, our what we do is those three things.
No, that's great. That's great. No, I like that. Now, did you see what I put up on the screen about the intelligence community? Are those all folks that you'd like to reached out to you?
Absolutely.
Okay. Okay.
Yeah.
So again, like the Air Force Intelligence, Army Intelligence, CIA, Coast Guard Intelligence, Department of Energy, Department of Homeland Security, State.
Another nice thing that Jim didn't talk about, and he could probably talk about it as well. He architected the system so it can be siloed off. So each individual agency can have their own unique portion and have roles assigned and permissions granted to different areas. So there isn't any cross information sharing it, or they can share it if they want, but if they want to keep it grouped into their own silo of intelligence, they can do that as well. So Jim, do you want to talk about that a little bit? I don't know.
Yeah, so let me explain it this way. First off, we don't know how people are going to want to use. When we were architecting it, we didn't know all the different ways this platform can be used. Typically, the way that things are built, most application platforms, is that for one company or one organization, one agency, that each one gets their own copy, okay? And that's the way that they would do siloing of the data off. The way that this was architected is, of course you can do that, but I added another layer to it, and that makes it so that the data, there's a term that's called federated and unfederated data. And what that means in English is that federated data means that even in one application, if we had one copy for the entire federal government, each agency of the government could have their own separate database. So it's one system where everything all works together and is exactly the same, but it's the same installation, but each one of them gets their own database, so there's no cross-contamination of the data between them. We can do, that's called federated data. Unfederated data is data where it all gets thrown into one big pile, but still can be separated out. But technically, you may end up getting some cross-contamination of possibilities there. Ours can do that. So when you sign in, you work for an organization, you're associated with some organization, and you can be associated with multiple organizations. You can pick which organization you're doing the work for, and then you're only being able to see the products and services, the tools, the data that's associated with that organization. But again, like I said, the way it's architected is that you may only have an installation that has only one organization in there, and everybody is in that one. But it can do the federated and unfederated data. And Jerry was talking about the more practical let's talk about it from a military perspective. The thing is that this is setting up the separate walls to make it so that only people with certain security clearances. So these organizations may really translate into security clearances. And then on top of that, there's a full typical roles-based security model that's put on top of it that determines which applications and features each individual has the ability to have access to.
Wow, that's impressive. I think that just listening, I think you're talking to really, really high level, intelligent people that understand this stuff. And so they're the ones that you probably want reaching out to you, Jerry, Jim. I think that, the average Joe is just not it's going to be beyond their comprehension.
Sorry.
Yeah. Well,
but that's okay. No, listen, look, again, I mean, we need people at that level, right? Thinking about how to solve these big problems, because we know cybersecurity is a major issue. We hear about it almost every day in the news. The administration's putting a lot of money into cybersecurity, right? And so that's a major issue. And then also when you look at not just cybersecurity, but if you look at the infrastructure, right, that supports, like, for example, some of our electric grids and our power grids that are all ran by computers, those things become threatened as well, right, from bad actors.
So
Jim, go ahead and tell them about the. Go ahead, Jim.
Okay, so there's a couple. Oh, you hit on some really big things there that we know a little bit about.
I'm paying attention to that. I know what's going on. I'm in this industry, guys. I'm paying attention. We're looking for people like you that can solve these problems. So
yeah, so there are two different things associated with that. The first one is there's the Protect the Grid project. that we are associated with. I'll put it that way. We talk to those guys and are trying to see what we can do to help on protecting the grid. But there's an actual initiative called Protect the Grid. The second thing is that our technology, one of the issues, Jerry used a term when he was talking about the no code, and he used the word IoT, the Internet of Things.
Right.
Okay. And the Internet of Things, for people who don't know, is all your smart devices. Well, the electric grid, industrial systems were built with technology. A lot of them were built with technology before the internet was invented. And when the internet wasn't there, when you connect, they then started connecting the devices together. Even before the internet, they started connecting them to control the grid, to control power systems, to control everything. The problem came in that the internet came, and now everybody wants to be able to see what's going on the grid real time. So let me connect in. So they had to connect all these devices up to the grid. Right. And now they have a problem because now hackers can get in there and do bad things.
Right.
Well, our system in our no-code, with our no-code technology, it can talk to all of those old technologies that are now connected to the internet. We can monitor all the traffic and using artificial intelligence, determine that these are the normal patterns of communication. So let me give you an example. I'm not going to go to the grid. I'm going to go to a manufacturing process. Okay. Let's say it's a pharmaceutical. Okay. And a pharmaceutical, what they do is they have automated systems that put all the chemicals and different biologics and whatever into big vats and make things, right? And now imagine that, and that's really controlled process. A bad actor goes in there and he can make it so that it's a bomb, that it creates a bomb,
right?
A biological weapon that explodes right there, right? And so if a bad actor is coming in with our technology monitoring the traffic, because we can monitor with our no-code technology, actually, we can monitor all the traffic that goes on, tie that into the AI. The AI says, these are the types of messages that are normal. These are the types of messages that are not. These are bad actors. Something is going on. Let's stop that. And so what we've done is we've been doing work on building systems for the purpose of stopping some of these kinds of things. And it's not, it goes into, our pipelines, our oil pipelines are another example of something that's controlled,
Right.
And the problem is that having access to the internet, people expect and want to be able to have access through the internet.
Right.
If you want something to be really secure, don't have it connected to anything else. If it's connected, bad people can get to it. So now you need to be smarter than the bad people by putting in some countermeasures and using AI to be able to detect the bad actors and then be able to shut them down is kind of one of the things that we do.
Wow. No, that's incredible. That's incredible. Listen, guys, I think that you've punched us in the face today. So this is good.
Sorry.
I loved it. No, I love every bit of it. I mean, I think this needs to get out there and people need to hear about your technologies, and definitely how, what's the best way to reach you? What's the best contact information? I have your website here. I've got you pulled up.
You can either email us at, jerry.ladd@ciworks.com or call the number on the
site. Okay.
Our website is CIWRX.com.
And the number here is 402-679-1334.
Yes, that's I'll pick that up at any time. I carry that with me every day, everywhere.
No, I love it. I love it. Listen, thank you so much. Any final things that you'd like to say before we close out today?
Just thank you, Eric. I mean, it's I read a little bit about you. You're kind of impressive. I mean, in 2007, I'm not trying to patronize you, but just telling you that you've done a lot in a little amount of time. I mean, we're old timers. You're the new guys. We're kind of trying to hand this baton off to you guys. So that's kind of awesome. Thank you.
Jim.
Yeah, thank you very much for letting us on and for listening to me rant about some stuff that we're pretty passionate about. We're just here to help.
Oh, I love it. Hey, listen, thank you so much. And again, as always, all the information from today's conversation will be on our website at govcongiants.com/podcast.